Sizes of eruptions. Volcanic eruptions come in all sizes: small, medium, large, extra large, giant economy size, and super huge, knock your socks off more than you could possibly imagine size. Go figure. Giant eruptions can literally affect the whole world. On the other hand, small eruptions may affect only a single hillside or valley. Let's look at the characteristics and effects of volcanic eruptions of different sizes, starting with small and working our way up. How close? A small volcanic eruption may consist of a single small burst of steam and volcanic ash, such as the initial eruption of Mount St. Helens, or a single lava flow like those that make the local evening news in Hawaii. By exercising some caution, you can view many small eruptions from a reasonable distance. What is reasonable? It all depends on the type of eruption. Explosive eruptions, the high water, high silica, even small ones, are best seen from a distance of miles. On the other hand, effusive eruptions, low water, low silica, can be viewed from quite close if you position yourself properly. Large flows of very fluid lavas can attain speeds of 50 to 60 miles per hour, so you would not want to try standing in front of such a flow. With care and proper clothing, however, these flows can be observed and even sampled from the side at a distance of a few feet. C.R. Chapman tells of two volcanologists walking beside a lava flow during a long hike to the source vent. They had been carrying a frozen pizza with them for a snack. When they grew hungry, they decided to cook the pizza on the solid but hot crust forming at the edge of the lava flow. Unfortunately for their stomachs, while the pizza was cooking, the oven of unstable rock crust broke free and drifted into the flow, carrying their pizza out of reach. Because wading through liquid rock is not recommended, they went on, hunger unsatisfied. Look at the picture there of that person, close to a lava flow. Some flows are very slow, and even the fastest flow eventually cool, slow, and stop. Slow here means human walking speed or less. You can observe slow flows from any vantage point, front, side, even on top in some cases. G.A. MacDonald tells of a volcanologist who had observed a slow-moving blocky flow through a long, hot morning in Hawaii. By noon, the flow had appeared to stop, and the volcanologist decided to have lunch on the top of the flow. After sitting and eating for a while, the volcanologist noticed that the surrounding scenery was moving past. The flow he was sitting on was still creeping along and was not dead after all. How large is large? There is no universally accepted scale comparable to the Richter scale for earthquakes for classifying the size of volcanic eruptions. However, one useful comparison is the volume of new volcanic rock blasted out by an eruption. Volumes of new volcanic rock are represented on this page in two ways: by the figure at the right, which pictorially compares ejected volumes. That's this one right here. And the table below, which shows similar numerical data. The designations of small, large, major, and great eruptions are simply descriptive and are used only to draw attention to the enormous range in the sizes of volcanic eruptions. So if you click on this one, you can see how Yellowstone is a giant eruption. Tambora is major, really huge. Even, Krakatoa and Mount Pinatubo are large. Vesuvius, if you heard of Vesuvius and, the movie, don't know how realistic it was. But they're all big compared to Mount St. Helens. Look at Mount St. Helens. It's just a quarter compared to all those. And then this here can tell you large eruptions like Kilauea, Mauna Loa, all these Hawaiian volcanoes, including Vesuvius. Major eruptions, it's got Pinatubo in the Philippines, Krakatoa, and all these. Some of them erupted a long time ago, 4,000 BC. That's like over 6,000 years ago. Great eruptions, you've got this Valles in New Mexico, but that was 1.4 million BC. And then, of course, the great eruptions, you got Yellowstone, and all these here. So you're talking, those are the ones that are going to wipe out life on Earth. But yeah, so Mount St. Helens doesn't even fit in this category because it's not large or major or great. Let's go to page 2. Size of eruptions. Small volcanic eruptions. The volume of volcanic material tossed out in the bursts or flows of small eruptions is relatively small, a few football stadiums full, equal to a few million cubic feet or a few 10,000th of a cubic mile. No worries, mate. After all, the inhabitants of the island of Stromboli in Italy simply ignore the virtually constant thumps of red-hot lava bombs being tossed out of the vent of their resident volcano. Of course, just how big or important a particular eruption appears depends largely on how close you are to it at the time. Even a small steam explosion seems huge if you happen to be standing right next to the vent when it blows. And a single lava flow seems catastrophic if it happens to go right through your bedroom. Small eruptions may also be of concern if they are harbingers of bigger things to come. A large eruption. Large volcanic eruptions. Large eruptions often make national and even international headlines, so you have probably heard of some of these. El Chichon, Mount Redoubt, which nearly nailed a passing jetliner, and of course Mount St. Helens. Large eruptions affect areas as far as tens of miles away and typically eject a few tenths of a cubic mile of volcanic rock and lava. Depending on the local population distribution, large eruptions can be very destructive of life and property. Potential hazards in these eruptions include huge blasts of superheated steam and pulverized rock, rock avalanches, massive clouds of volcanic ash, asphyxiating gases, and in the cases of volcanoes with snowcaps or glaciers, giant mud flows. We get that here in Washington. The eruption of Vesuvius in 79 AD buried the towns of Pompeii and Herculaneum in Italy and killed thousands of people with falling ash and poisonous gases. The main blast of steam and rock from the 1902 eruption of Mount Pelée on the Caribbean island of Martinique destroyed Saint-Pierre in less than 2 minutes, killing all but 2 of the city's 30,000 inhabitants. Wow. Ironically, warnings about the dangers of an imminent eruption were downplayed by public officials anxious to keep the voting populace in town for an upcoming election. Unfortunately, the volcano exploded 3 days before the scheduled election, annihilating both electors and potential electees. So it backfired on them. Can't mess with Mother Nature. Mudflows triggered by a 1985 eruption of the Nevado del Ruiz in Colombia swept through a small town and killed 25,000 people. In contrast, only 57 people were killed in the 1980 Mount St. Helens eruption, largely because of its remote location and the effectiveness of public warnings. As important as large eruptions appear locally, they are still relatively small compared to our next larger size classification of major eruptions. Major volcanic eruptions. Mount Pinatubo in the Philippines in 1991 and Krakatoa in Indonesia in 1883. Hollywood even made a movie about this one. Were tens to hundreds of times larger than the eruption of Mount St. Helens and are classified as major eruptions. These eruptions are often caldera-type eruptions. They eject many cubic miles of material and affect areas around them up to hundreds of miles away. Everything about major eruptions must be written in superlatives. Major eruptions are incredibly destructive. The very islands on which Krakatoa Tambora, Indonesia, 1815, and Santorini, Greece, about 1500 BC, had stood simply disappeared into the sea during the eruptions. They were wiped out by those eruptions. Tambora spread thick layers of ash and floating islands of pumice across 2,000 miles of Indonesia. Superheated steam and ash from Krakatoa's main blast killed and burned people 30 to 40 miles away on the Sumatra coast. That's nothing compared to what Mount St. Helens did. Mount St. Helens went, 10, 15 miles with the blast zone? And the lava flows went farther, but nothing compared to this. Krakatoa also spawned tidal waves over 100 feet high that swept the coasts of Java and Sumatra, claiming most of the 37,000 lives lost in that eruption. The destruction is so great and widespread and large and especially major eruptions that eyewitnesses often describe the eruptions and their aftermath as the end of the world. Major eruptions are incredibly loud. Noises from the eruptions of Tambora in Indonesia in 1815 were mistaken for nearby cannon fire in European settlements 200 and 750 miles away from the volcano itself. In each community, nervous military leaders sent out ships and soldiers to investigate what were thought to be attacks on nearby outposts. If the main eruption of Mount St. Helens had made as much sheer noise as Tambora, it would have been heard all over the United States. Major eruptions can affect weather around the world. Clouds of ash and sulfur-rich particles thrown into the stratosphere by large volcano blasts reflect part of the sunlight reaching the Earth, causing cooling of the atmosphere. The larger the blast, the greater the effect. A global cooling of about 1.5 degrees Fahrenheit, detected by modern sensors, continued for about 2 years after the Mount Pinatubo eruption. Cooling was so severe following the Tambora eruption that 1816 was called the year without a summer. That's how much damage it can do. Or 1800 and froze to death. Cold temperatures and killing frosts in Europe and New England in America caused extensive crop failures and resulted in famine in post-Napoleonic France. Many farmers in New England left for the frontier in New York in search of better weather, swelling the American move west. So that could have caused why they moved, because they were running out of food because of this cold spell that came from a volcano, reflecting the sunlight and the heat that we need to warm our planet back out into space. Major eruptions have even been responsible at times for literally changing the course of history. The Mataram Empire in Java was apparently destroyed by a major eruption of Merapi in 1006 AD. The course of Mayan civilization was changed when a major eruption of Ilopango in El Salvador destroyed the highland Mayas around 300 AD. Subsequent shifts in population, trade routes, and resultant economic power gave a great boost to the development of the classic Maya civilization. And the eruption of Santorini in the middle of Bronze Age Europe apparently caused the destruction of the advanced Minoan civilization on Crete and the surrounding islands and allowed the expansion of the early Greeks. If it wasn't for that, maybe the Greeks wouldn't have been so dominant. Ash clouds and tidal waves from Santorini may have also reached Egypt about the time the Hebrews were leaving the country and given rise to the stories of the biblical plagues in Egypt. Lest we become complacent thinking that major eruptions only occur in other parts of the world, just remember that the blast that destroyed Mount Mazama to form the placid-appearing Crater Lake in Oregon occurred only about 7,000 years ago. Almost any of the Cascade volcanoes could do a repeat performance at any time. Page 3. Sizes of eruptions. Great eruptions. As large and devastating as major eruptions are, they are not the largest volcanic eruptions known. Wow. None of these largest or great eruptions have occurred in historic times, thank goodness. We have only gigantic deposits of volcanic rock as eloquent evidence of their reality. So all our inferences are based on this evidence. Great eruptions emerge from two types of volcanoes: fissure eruption and giant caldera. In both types, the volume of volcanic rock deposited on the surface of the Earth during a single great eruption can be many hundreds of cubic miles. Hundreds of cubic miles? Hundreds of times larger than the major eruptions mankind has known. Giant caldera eruptions explode with violence, noise, and destruction that defies description. Try to imagine an eruption 10,000 times larger than Mount St. Helens. 10,000. Several giant caldera eruptions are known to have occurred in the United States. The Valles caldera in New Mexico expelled about 100 cubic miles of ash that still covers much of the middle of the state. The Long Valley caldera in southwestern Nevada ejected over 150 cubic miles of ash that now makes up the thick layers of rock and mountains all over the West. But the largest of these eruptions in the United States came from a fairly recently recognized giant caldera right in the middle of Yellowstone National Park. This caldera, some 30 by 50 miles in size, covers about half of the park, as seen in the map on the left. And look, Old Faithful is right there. There's Yellowstone Lake, and the West Thumb right there. And there's a canyon. So right in the middle of Yellowstone National Park is this giant caldera. The Yellowstone caldera is much larger than the crater on Mount St. Helens. The explosive ash deposit from Yellowstone is also much larger than the deposit from Mount St. Helens, as shown on the left. So Mount St. Helens did this much. You remember I showed you that. And then we've got here the Mazama ash, which is bigger than Mount St. Helens. And we've got this one over here, looks like the Bishop ash. But this big, gigantic yellow, dark yellow one, yeah, that would be the volcanic one from Yellowstone. That's going to take out look at it, most of the United States. The Yellowstone eruption blasted out a phenomenal 300 cubic miles of ash in a thick blanket that extended from California to the Mississippi River. From California all the way to the Mississippi. All life within hundreds of miles must have been extinguished in less than an hour. And remember what I just read earlier in page 2, all that ash reflects the sun back out into space, the sunlight, the radiation, so it'll make a global cooling that will further destroy life on our planet. But in giant fissure eruptions, sometimes called flood basalt eruptions, the Earth simply cracks open and disgorges vast amounts of fluid basalt, the low silica stuff. These giant outflows are not explosive, but they may continue for weeks without a break, inexorably burying vast areas under a sea of liquid rock. Flood basalt eruptions also come in swarms. As soon as one finishes, another begins. Multiple outflows from the same set of cracks continue for thousands of years, creating enormous barren plains of rock. The largest flood basalt deposit in the United States is the Columbia River Basalt. And that's a group which covers the eastern third of the state of Washington, a quarter of Oregon, and part of Idaho. Boy, we are volcano central. One individual layer of basalt, a single eruption, covers 15,000 square miles to the depths of 100 feet or more, a total volume of about 600 cubic miles, twice as much as that Yellowstone. The entire Columbia River basalt covers 50,000 square miles to depths of a mile or more, with a total volume of 25,000 cubic miles. All of this stuff came out of a group of cracks, each 30 to 50 yards wide and tens of miles long, in western Idaho. Flood basalt volcanoes are the largest known deposits of volcanic material. What is up with that? That is crazy. Given what we know about what a major eruption can do to the world's environment, we can only guess at the conditions great eruptions create. However, we do know that many of the world's great flood basalt eruptions correspond in time with some of the great periods of extinction of life in Earth's past, which indicates extremely challenging climatic conditions for extended periods of time. Extinction happens during these eruptions. That's what that means. Fortunately, the larger an eruption, the less frequently it occurs. Whew! Thank goodness. Many small eruptions occur around the world every year. Large eruptions occur every year or so, and major eruptions occur on scales of decades to centuries, while great eruptions, well, the Columbia River basalt, the world's youngest major flood basalt deposit, is about 15 million years old. Does that mean we're due for another one? I sure hope not. The Long Valley and Valles calderas blew up respectively about 11 million and 700,000 years ago. The Yellowstone caldera erupted about 600,000 years ago. Good, let's hope it's got plenty of time before it erupts again. Certainly no great eruptions have occurred during recorded history. It would seem that humanity is unlikely to experience a great eruption anytime soon. On the other hand, the Yellowstone blast is only the latest in a string of eruptions in that area that occur every 600,000 years or so, and it's about that time again. What?